Welcome back from morning tea. Just a little bit of housekeeping. BDA, who are our joint event organisers, and CTBUH registration forms are on the registration desk at the back. So if anyone would like to join either group, we would welcome your membership. So I hope you all enjoyed the first session. Certainly it created a lot of discussion at morning tea, and I'm certain that you'll enjoy this next session. We're very lucky to have Ahmad Abdelrazaq speaking to us about the challenges of designing tall buildings. So he's going to give a little bit more of a technical, I suppose, overview of how challenging it can be to design tall buildings, but then also talking about some of the impacts that has in and around our cities. Following Ahmed's presentation, we have Joyce Lee from Hyder Consulting will come and moderate a session of Q&A. So Ahmed is a Senior Executive Vice President and Business Development, Technical Proposal Division and Head of High-Rise and Complex Building Division of Samsung, CT and Corporation. It's a very long title. He holds various professional memberships at high management level, including member of the Steering Committee of the Council of Tall Buildings and Urban Habitat, the American Concrete Institute, American Institute of Steel Construction, American Society of Civil Engineers, Structural Engineering Association of Illinois, and Earthquake Engineering Research Institute. Probably a good thing to be on when you're designing tall buildings. He has led many landmark projects throughout the world, including the Burj Khalifa, Dubai, the tallest building in the world at 828. I wonder how long it will hold on to that title, maybe for a little while. The Jin Mao Tower, Shanghai, China, the Kowloon Station, Hong Kong, the PRC Hotel Villa Olímpica, Barcelona, Spain, and the Millennium Park Project, Chicago, USA, and Yongsan Landmark Tower, which is a 620-metre tall tower, a 111-storey tower, Seoul, Korea. And I have to say, with Ahmed, the list goes on and on. So he's been involved in a lot of tall buildings, and we're very lucky for him to be here today with us. Joyce Lee, who will be moderating the session later, is an Associate Technical Director, Building and Structures with Hyder Consulting. Joyce is experienced in the different aspects of structural engineering for both local and international high-rise projects. She has been involved across various stages of project, from master planning to concept design through to detailed design and construction handover. Her experience has led to her successful involvement in the tender design of Barangaroo in Sydney, Dubai Tower in Doha, 60 Station Street, Parramatta, and more recently 177 Pacific Highway, North Sydney, and 1 William Street locally here in Brisbane. So please welcome Ahmed and Joyce to the stage.
Thank you very much for your introduction, and this is my first time in Brisbane. It's really very pleasant coming from Korea with a completely different weather. It's very nice, and also it's very nice seeing all of you here. Thank you very much for the invitation. Today, the focus of the talk a little bit more technical aspects in terms of what makes tall buildings very successful. As most of you know, Burj Khalifa, for example, we were able to complete 162-story buildings all the way to the top of the spire in about 36 months. When you think about that, I think it's quite a challenge. It didn't necessarily come completely from construction aspects. If the design concept is not designed in an efficient way that allowed the mechanization of the construction process, I don't think that can be achieved. So the design principles, especially in structural design for a tall building, is extremely important. Toward the end of my presentation, obviously I'm going to talk a little bit about smart cities and what really makes them smart. As most of you know, by 2015, probably 60% of the human population will be in a denser city, very, very urbanized, and we can no longer spread horizontally. We have to go up vertically. And the question is, what do we do to the infrastructure to make the building and the city planning operate in the most efficient manner, not having a high demand on the infrastructure like what we see in the US today. A good example of some of these cities, for example, is Singapore, Hong Kong, where they are very dense, they operate very efficiently, they use the least amount of energy, and also from a sustainability standpoint is where we need to go. So today these are the two major, and what are the technologies that we have today available to make this city more smart, more efficient in every aspect. Just a brief, many of you probably take 1 minute. I will not spend more than that, just to let you about Samsung. Most of you know Samsung as being a mobile phone company or electronic company, but actually significantly more than that. We have about 500 number of employees, and our revenue is about $350 billion, which is huge. It started just a small company, and to build the tallest building in the world and some of the longest span structures, and also from electronics to be number one. We all operate. Samsung CNT Construction is really the mother company of Samsung, of the whole Samsung group. Now it's only 5% of the revenue, but essentially it is the mother company of Samsung. We all operate under one philosophy as a group, and demand, we do believe in our people, we believe in change, we believe in excellence. Integrity is very important to ourselves and how we conduct our business. And also co-prosperity is extremely important. Again, construction, we do civil, planned, housing, and also trading is a huge. These are just, we work on about 300 projects in 32 countries. We haven't, obviously, we're doing civil structure here in Australia. We haven't done much buildings. But as you can see, we're very well diversified in high-rise, healthcare, bridges, power plant, nuclear power plant. These are some of the flagship projects we have in high-rise, airports, mixed-use, healthcare, and we have our own development company in terms of residential. We do everything from feasibility study all the way to final construction as a developer and operation and management. Healthcare, same, airports. Again, the fortunate thing about Samsung, because of we have about 34 affiliates, we tend to rely on other affiliates that makes the building works efficiently, and trying to use some of the latest technologies that we have, especially when we're building our buildings, such as SDS, S1, JL Industry. And SDS is pretty heavily involved in some of the city planning, full soul, to make it building very efficient. So. Anyway, these are some of the projects, some projects we completed. These are some of the projects that we have now. As you can see, diversified in design-build projects, pre-construction service, working everywhere, Middle East, Southeast Asia, Korea, Saudi Arabia, Russia. So we haven't been here. So we hope we can do something here. One of the things that I want to talk about is really what is going on with the industry in terms of paradigm shift in tall building topologies, and what does it mean from design and construction planning in terms of very iconic structure, very complicated structure. How do you make them efficient? Obviously, we remember cities by their structure and tall buildings in particular, looking around from Hong Kong to Singapore to Shanghai to Incheon to Korea. And the Middle East, when we first started working on Burj Dubai, there was nothing. This one was a complete desert. Actually, not a single building exists. And concentration of cities in this kind of environment is extremely important in a harsh environment. So being tall is actually more environmentally and more sustainable. The other thing that happens in Dubai is it pretty much give the architect free hand to do whatever they want in terms of design. So they have to use new technologies that in some sense push the limit in what we do from a tall building planning standpoint. And as you can see from some of the structures that have been proposed to Dubai, they are pretty heroic. These are the new topologies that we see in tall buildings today. And it's almost, when you look at it from a planning standpoint, construction standpoint, you say, where do I start? What do we need to do to make the building efficient? The other thing is buildings become very tall and very slender, which means that when we designed them, we started seeing completely different behavior than what we used to. So this is something that also has to be looked at it from a technology standpoint, from efficiency standpoint, and how you plan around them to keep them efficient. So we also started looking at different kind of demand. Tall buildings in general, they're all about technology. As you can see from early 1900s, pretty much a tall building was 10-story building, and through the technology it evolved significantly from using of steel. And at the beginning of the century, we thought of concrete is not usable actually for tall buildings. And when we built Burj Khalifa, that was the first question: why concrete? This is the first building that we built as a concrete. The technology is here. Essentially, we cannot walk away from using the best material for tall buildings. And in fact, we are into a new challenge. When I first worked on the Guggenheim Museum in Bilbao, I was a young engineer, and the question is, when you look at such a building, how you build it. It's all about organization of a structure in order to build it without any kind of a temporary shoring. That makes the building very successful. But that success of this building essentially initiated a different trend in terms of tall buildings. They're becoming more unique and more iconic. And the question is, sustainability is how you look at it. Are they really sustainable in terms of efficiency and energy use? So some of the key factors that, in our perspective, that influence the design of successful, make building very successful is obviously structural system optimization is one of them, and selecting optimal construction method to build the building very fast. Right now, there are a huge amount of technologies that are available today, and we're still waiting as what's the next generation of tall buildings that we are looking at. By definition, tall buildings, they are about technology and management. High-rise design, they require high-rise design. Sometimes, and many consultants, a huge amount of coordination, more than 50 consultants. Structural stability is important. Fast construction cycle is very important. Nobody wants to wait for too long to see their building finished from economic standpoint. And most importantly, when building get complex, the verticality, especially very tall, they become very important. How do we keep the building straight so the elevator function properly, and so are the building services? They tend to be a long-term project. Communication is extremely important, and they require huge, massive resources, as you can see here from Burj Khalifa. So some of the factors that influence the design of tall buildings, obviously, is the financial. Financially, they have to be able to generate profit. Environmental, obviously, we all want to improve the living conditions for denser city, for large open plaza, free more land, transportation needs, energy needs, long life expectancy is there. And also, when you look around, do you think of what is really driving the architectural design of these tall buildings? Is it the free form? Is it creating a sculpture? Is it sustainability and architecture? All of these factors have influenced the design of tall buildings today. Historically, engineering design concept, definitely what drives it, especially structural design, wind, engineering, latest material and construction technologies. Burj Khalifa, believe it or not, during the initial design stage, what drove the design is how do we manage the wind load on that building, and how do we make it not susceptible to vibration and perception to motion. So the architect himself said, okay, what do I need, Adrian Smith at SOM, what do I need to do to control that? So we gave him a design that's pretty to control the wind, and essentially he created a beautiful building driven by mostly engineering. But the cost, always we worry about the cost. Shape and geometry is important. Size of the floor plate, structural solution, in terms of optimization and minimum material that we use, which has direct impact on the embodied energy on the building. Facade, vertical transportation, environmental strategy and sustainability in terms of the energy that we use, site conditions, market conditions. As I mentioned earlier, sustainability and environment is very important. When we look at it, and cities with a denser environment tend to be a little bit more sustainable. And as you can see from this chart below, almost transportation, womenized transportation is extremely important, where people live and walk to their office rather than drive. And also what the material that we need to make buildings also takes a huge amount of energy. So the energy is very important. For example, if you look at the study done by Marshall Strabel at SOM, this is a picture that I took of the city of Seoul, and if you look at Tokyo, I mean, we can't spread like that. And if you look at what happened in Burj Dubai, if we were to use the same amount of area that we put in the tower, you need much more area. It has much demand on the infrastructure, and a very harsh environment like Dubai is not that nice to do such a thing. The embodied energy is extremely important also, as you can see here from this chart. The structural solution, what you see here is the one. All the other disciplines does not impact actually the cost of the building as much, because everything is repetitive. But when you look at the structure, as the building gets taller, the stack effect, they start occupying a very large % of the floor. And as developers, what you want to do is, if you don't have maximum efficiency on the building, then the return on investment is not that much. So we have to be very conscientious about that point. And so the structural system optimization become very important. How do we maximize the use of the material without paying much penalty for the structural solution? So gravity load management become very important. Wind engineering very important. We have to address all these issues: vibration, structural health monitoring, utilizing of advanced technology. All of these things become very important. What you see here down at the bottom chart, I don't know if I have a laser, but it may not work. Over here, essentially, this is for tall building. If we were to be optimum, this is where you need to be. But when you add wind and seismic, then the added material become very significant. So for every project we do, we really need to remain at this point. And that's what we had done in Burj Khalifa, essentially. There is no penalty for the lateral system. Many structural system has been proposed for tall buildings that are very extremely efficient for use of material, such as if you look at Chimney Tower, for example, in Shanghai. It's extremely efficient. It's a very tall building, but it has about 85% efficiency, which today, if you look at some of the point tower in Shanghai area itself, you will never see this. So the organizational plan of the building and integration of the structure and architecture become extremely important. So the only penalty really that we paid is an outrigger that's very short here. So the rest of the building here is completely free. And almost the core is in the middle. It's not that much. Burj Khalifa, essentially we did the same thing. For example, if you look at, if I were to build a building just for gravity alone and calculate the amount of material that we need, you will see this chart here. And in reality, because of the minimum number of sizes, we needed that. So practically, the amount of material per square meter on Burj Khalifa is about 0.53 meter cube per square meter. So if you take any building in this city and you compare, you're going to be about 0.6, 0.7, which means the organizational plan and how you plan the building is extremely important. The other one is constructability aspect. Practically all the column sizes never change size, from bottom to the top, 500 millimeter. And as we need more building, we just added more modules to the building, just like you're building the pyramid. So no column change size, no wall change size, no change in the reinforcement. So all of these events essentially resulted in a huge amount of optimization, not from also design, but also from construction planning. And also the other thing is separation of the vertical construction from the horizontal construction. The other aspect is wind engineering. For example, in Burj Khalifa, I've been measuring it for the last few years. The acceleration is very, very benign, very small. So we do a lot of planning related to that issue. So all of these things, actually implementing the wind engineering aspects as part of the design, essentially can help you reduce member sizes, reduce the demand on the building, have a better and safer design with less material, but it has to be embedded in the planning. And what my experience, planning for wind engineering sometimes gives you really very exciting design, not necessarily sculptural, but very exciting, such as this building, which is about 500-meter tall buildings. It's very, very highly efficient, but also it performed very well in wind. But when you don't plan it and you do it randomly without doing a lot of planning, you end up having a little bit more complicated structure. It's still very interesting, still sculptural, but it doesn't mean it is better. So ultimately, how you operate, the efficiency of the building is extremely important. These are some of the things that, obviously, some of the hand sketches I made when I was at SOM. In terms of planning, how we change the shape of the building to reduce the wind effect. What you can see here, the building vibrates at a certain mode, and also the frequency of how the wind forms around the building. If they are the same, then you have a problem. But this one, with this building, we completely separated. So the building is moving one way. It doesn't care about the wind anymore. So these are the kind of things that we had done, and the wind effect is just fighting itself. So the building is sitting here, and the wind is blowing every which direction. The building doesn't care. These are other things that we're doing here. What we see today, damp structures, historically we have not really used them. We thought if you add damping to the building, it would create a problem, but actually it is not. Right now we're seeing more technology embedding the damping system as part of the fourth dimension of the structural design, in which we can have a better control over the design. These are just, examples of using water tanks, to dampen the motion of the building, especially for tall and slender. Significant benefit. There's damper here. Also, the seismic design, as you can see, a lot of problem. Whenever there's a big seismic event, we see huge amount of loss of life, huge amount of city just practically become not functional. And do we need, when we do city planning, to continue to design that way? For example, what happened in New Zealand, or what happened in Kobe, what happened in Japan, the losses that we get is unbelievable. Huge demand on the whole city, the infrastructure, and the technology is here today. Why do we have to do this? Essentially, right now we have enough technology in which even under extreme seismic events, the building still need to function. And there is no reason to do it, not to do it, especially for essential facilities. And the questions, are these really more expensive? I don't think so, because if we do conventional, what you follow the code, the building tend to be more expensive than if you were to use these damping devices. Essentially, you get a safer design, more controllable design, less expensive design, but you have to plan it. And the city has to allow the flexibilities in performance-based design, so we have essential. Now Japan and other places in the US, definitely moving that way, and as we plan the city, we should continue to do that. And they are very simple devices available. They become very inexpensive, even for super tall building. This is one of the concepts I developed essentially to dampen the motion with a very limited, like a viscous dampers, like a shock absorber that you have in a car. And essentially, it reduces a lot of demand on the building. And this is even for super tall. These are the other sketches. It's about 1.6 kilometer building, in which buildings are linked together with the bridges, in which we can incorporate such a system. So they are available today. So when engineers plan is what are the things as a developer, as an owner, what is the least expensive, the most economical, the safest design I can have, right? So today, engineers are faced with a lot of choices. Structural material, high-performance steel, high-performance concrete, fire-resistant casting, composites, computer technologies that tell us everything we need to do, smart materials that can change its characteristics with time. Architectural constantly wanted the lighter building, better, more efficient, and also wind engineering, seismic engineering, extreme events in case do I have redundancy and robustness in the building in case some unusual event happened, the building remains safe, and the structural detailing and redundancy. So every project we went through the same choice, is what is the most economical one I can have for the building. And that's a matter, how does it work? Sometimes designer by himself will not be able to design. Engaging in the contractor early will definitely help the process very well in this process. And we have seen also a shift in paradigm in terms of what kind of building we have in the future. Initially it was all, now we're seeing more residential building, we see more concrete, more composite structure. Fortunately, some of the most recent development that we have, which is concrete technology, continue to evolve. At the beginning of the century, we have cast iron, which is about 200 MPa. Today, I can cast concrete on site up to 150 to 160 MPa. So practically, you can develop a technology in which you can make the building in the making. High strength, modulus of elasticity, mass damping, very difficult, very fast to use. We have a concrete formwork system that allows you to fast build the building. Carbon fiber, high strength, SRC. And the most important thing, I was very fortunate actually to work on Burj Khalifa, where I work on the design. Then I moved in Samsung. I did the construction. And then I was fortunate enough to implement one of the biggest mega research monitoring program in the history of tall building as it stands today, in which to compare my design to what I actually measured. We do to a wind tunnel, we pay $1 million to actually measure what the acceleration, expected acceleration. Right now we have a monitoring program 24/7 on the building that give us a feedback on the building behavior, measuring gravity, measuring column shortening, give us everything about the climate control, measuring lateral displacement, measuring the overall behavior. And right now, with the new technology, it's almost like I have the building in a hospital, practically. What we have is practically the whole columns are monitored. I can get the strain, the stress, like you going into a doctor and measuring your blood pressure. We measure the strength and strain in the building in real time. This is actually implemented in the building, and we get all the data to ensure verticality. We get total information in terms of what happened within a column itself, temperature rise, increase in strain with time, to give us a better prediction in terms of the shortening of the building. Lateral displacement allow us to measure the deformation of the building, building settlement, the strain in the foundation, control the verticality of the building during construction, where we get it real time. Every month we run the analysis, compare it, and ask the construction team to make adjustment as necessary. So these are all the tools that we have today. So today we have implemented, as an example, which I think it's important also for, as we do in the big planning city, how do we get the feedback to improve the codes, to improve the standard, to improve what we are doing? Codes get more and more complicated. Do we need to do that? Essentially, we can, with the new computer technology, we can implement such a system. For example, in Burj Khalifa, you have somebody measuring his health. We're doing the same thing, where we get measuring the acceleration, displacement, weather, and so on and so forth, whether it's due to wind or earthquake. I have a 24/7 watch in terms of what's going on in the building, and that gives us a feedback and able to compare our design to what we have predicted. And during construction even, there is a seismic event that happened. I was able to immediately capture the data and correlate what we designed versus what we measured, and to assure us that the building is behaving the way we designed it. And so the technology is here. This is just in real-time movement that you can see. So for all essential facilities, as we build taller buildings, I think it's a great benefit even to the developer to understand the benefit of this. When we first initiated this program, the client didn't want to pay. So I went to my CEO, I said, please give me some money. He said, how much? I said, $500,000. I instrumented it. Today, it's part of building management system at Burj Khalifa. And in fact, they asked me, can you please update it again? So we're constantly updating it because it's a huge benefit to them in terms of measuring the temperature, demerging balconies, monitoring the building behavior, looking at what to do with the elevator. It's become part of the building management system, actually, surprisingly. So other things that I cannot talk about because of the short design planning, from sustainability, cladding, MEP system, vertical transportation, stack effect, fire protection, construction planning, as I mentioned. These are a very, very large, massive scale project that require very large complexity. And imagine all the number of people that you have during construction. How do you get them out in case there is an event working on the building? So in fact, the fire and life safety on the building during construction is as important as a permanent, if not more, because I have more people that don't know what to do. These are the kind of things that we have to be mindful of in terms of designing such a building. Right now, BIM technology, I know there is a huge amount where we're still struggling to get it from design into construction. And with the present computer technology, for me, there is no reason actually why we cannot take the project from beginning to the fabrication plant using the BIM technology. The technology is available. In fact, we are doing a project in Singapore. We don't hire any subcontractor who's not familiar with it. And the minute they get into it, they realize, oh, I want my people to be on site, because it's becoming less demanding for them, less management, less coordination problems. So we took that on ourselves. As you can see, some of the Zaha Hadid project, all of these projects that you see here, including Cleveland Clinic in Abu Dhabi, all done using BIM. So we do have the technologies today, and we should be mindful to take full advantage of it, not only from design and construction, but also from operation and management standpoint. Modular construction, again, this is one of the things, how fast we can build a building without compromising the quality. This is just an example, but in fact, the Sears Tower in Chicago was a modular building, and how fast you build it. It's just, so a lot of things we can do. Right now, with smart homes, smart automation is another item that we have. Unfortunately, as I mentioned earlier during my presentation, fortunately, Samsung has everything you need to make a home very smart in terms of whether you're in-house or out of house, or you want to control the temperature, or you forgot the washer, or play your music, or whatever. You can practically, no matter where you are, you can have access to the home. Many of us, all professionals, you also need to know what the kids are doing. Practically it gives you the opportunity to do all of that. So all of these technologies right now, whether it is related to air conditioning, information technology, all the appliances, cleanliness, to control, to make your life a little bit easier. Again, these are LEED is also important for us. So some of the things that we also, with these complex projects, how you make them fast to build without waiting. A fast construction cycle, which I'm used to, actually, including Burj Khalifa. It's one of the things that I feel is extremely important for the complex project. So having the contractor, early contract involvement into the project is extremely important. Logistics, the planning, everything that you need, tower crane, to get the project up and running to build it fast. Fire and safety management during construction, as I mentioned, is important. Green technology. Right now, for every project, we have to start looking at renewable energy. And that is something that we have a very big research project within our facility that we have. Well, we are doing a lot of planning. We are doing a lot of cities. And when tall buildings are wind generators, tall buildings are also, from Burj Khalifa, for example, at the base of the building to the top, we have about 8 degrees centigrade differential, which means that the difference is there. And in fact, you could use it with a bit of a planning. This is a solar farm with solar chimney, what you see here. And if you raise it up a little bit more, you can build another city under it. So you can build actually a solar farm within, and then if you have the planning here, you can actually generate more energy using that kind of a system than you will ever think of all the renewable energy. So the ideas are there. they have not been implemented. This is just one of my sketches. Again, I'm not an architect, but I thought, what can we do to address some of these issues? And it can be done. There's no problem. This is about 1 mile high building. The future, again, it holds, as you can see, we're moving toward more, much bigger scale structure in which we protect cities in a much larger environment than we typically do. For me, high-rise building design trends, good architecture does really matter. So I think design should be responsible, should be sustainable, should be functional, and also should be contextual within the building. And as I mentioned, using all of these technologies are possible. You still can create a great structure, great buildings, and very efficient one. Again, for these large-scale projects, you do human resource experience, design coordination, technical support become extremely important. So having the right contractor on board to get involved early become extremely important to allow the whole design team to make the correct decision at the right time, and ultimately for the benefit of the owner, for cost saving, time saving, better quality, better product. So I will skip through those. So I think integrated early contract involvement is very important, and as most of you know, so I will not spend much time on it. The whole idea is based on what we know by 2004 NIST survey. Every year, almost we have $15.8 billion of waste because people lack of coordination and error, and having not people all involved into the process. So one of the essential principles of early contract involvement is to create a machine that really works, that allows the most benefit to the client in terms of value engineering, and also through transparency of cost. They can be assured that they get the best price, and also it's a win-win situation by de-risking the project for both the owner and the client. One last thought I have is really, again, it's going into how you get everybody engaged to work together as a partner in providing the building solutions in a fully integrated manner where people can build things fast. If you think about the World Trade Center, and maybe she knows more than anybody else, Ms. Carol, it was built in 12 months. There was no contract, practically. How many? Empire State. No, Empire State Building. Sorry, Empire State Building. Practically, it was built about 100 years ago, more than 100 years ago. It was in a shake of a hand. Everybody trusted each other. We're going to build a building. We're going to make it efficient, economical. It was done. It's probably this kind of a model that we kind of miss. People trusted each other. Today, we kind of drifted away from that. So I think having people engaged in a full spectrum on the design of these complex and complicated buildings, from planning stage, project management, construction, and operation, can add a huge value to the overall development. We are fortunate as Samsung C&T. Obviously, we have the technology, but also we have what supports it in terms of electronics, in terms of resorts, in terms of lighting, whatever. We have a lot of that. We also have, as I mentioned earlier, the technology to make everything customized. Again, packaging with all Samsung product as an example is one example that we are working on right now to trying to offer the client probably the most integrated solutions to make building very efficient. Essentially, we build cities. What makes a smart city? Obviously, Samsung is also involved in developing most of the software for the Seoul city, which is about 20 million people. How you operate the train, how you operate utilities, how you operate the lights, how you operate everything practically remotely. It is something that sometimes we are not incorporated as we develop in new cities. So we need to create city for smart life, city of elegance, city of fast transit, city of energy use, to minimize the energy through many aspects, and also for city for public safety, and also for city for public governments, in which you integrate everything, what you need from schooling to healthcare, so on and so forth. And with that, obviously, looking at the urban system, plus smart technologies, I think we can create some of the most sophisticated smart cities. And with that, this is the last slide, which is essentially how do we smart management for the entire city, and what are the technologies that we have today. So it's available. I think let's do it. With that, I end up my presentation. Thank you very much.
Thank you, Ahmed, for your very informative and intriguing presentation. So we'll have a question and answer session now. And I'll start off the Q&A with Ahmed. You talked a lot about building faster, optimization, efficiency. As we move into the next 10 to 15 years where we have to deal with the rising cost of construction, what do you see as some of the challenges and possibly, in your perspective, some initiatives to help overcome this?
I think modularization will always be very, very important right now. We cannot get away from it. Obviously, that requires a huge demand on the design team to complete the design early, to reduce less error, to allow for complete procurement, to allow you to check your design, to make sure that the quality that you are getting is there. Structurally, I think it's extremely important to incorporate the right kind of structure to allow for modularization. And there is no need why we cannot do it. Actually, it's just a matter of being able to put our hands together. But if your designer goes like this, contractor goes like that, and at the end of the day you put it for bid, it's very difficult to incorporate that. And I think there is an opportunity for us to integrate everything together to get, as especially developer, time is very important. Financing is a huge burden, right? So if we can incorporate some of these ideas into the design and incorporating some of the latest technologies, I think it would make a huge benefit to the over cities and communities, I think. And also to the owner in particular benefit.
I've got a question there.
Michael Macon, Ahmed, welcome to Brisbane. One of the things about Brisbane is probably most of the people in this room have spent their working lives trying to live in a bungalow on the ground, and so we probably don't easily relate to super tall buildings. One of the challenges perhaps for Samsung and developers like yourselves is, for example, our city. Our particular characteristic of Brisbane is it's a subtropical city. So if we build a tall building, opening the facade in a tall building actually becomes technically very complicated. What has been your experience with living and creating outside air movement into the upper levels of very tall buildings? Because it's one of the technical problems that we face in Brisbane.
I think we've been involved in many, many tall buildings. I think the planning stage is extremely important, and by understanding, if I understand the question right, is you're asking if you have a problem in terms of when it get taller in terms of the cladding. Okay, we do have again in Burj Khalifa, for example, it's one of the tallest. Let me stand up. I think a little bit easier. We do have a lot of balconies, accessible balconies. And it depends on the wind profile. And again, in Burj Dubai, they operate actually very often. But we do have places where, obviously monitored all the doors. In case the pressure exceeds a certain limit, everything gets shut down. So you have a chance to monitoring it. And at the same time, we have done similar project with a lot of operable window in Korea, where it is required by code, where people open the windows. One of the biggest issue with having operable windows and I think open to the outside is essentially the stack effects, especially depending on what kind of environment you're at. And that is something that we have to manage. So we have different experiences, depending on what your requirement, different way of dealing with with the issue, I think. But in terms of operable window, the key issue is to, especially if you allow the tenant to open whenever they want any windows in any room, then in that case, the detailing, the architectural detailing become extremely important, not to change the pressure. Because sometimes, if that is not taken care of, you have doors, you have whistling effects in the building, make things very, very uncomfortable. So it has to be done within the design. Okay.
Thank you. We'll take one more question from the floor.
Use 50 MPa. What technical difficulties do you have going to something like 150 MPa?
It depends on the quality control. Concrete right now, we have a huge amount of available technologies today that allow you to create a concrete mix. The question, how do you deliver it? And how do you make sure that the quality is achieved? Trust me, I think this is the first question I asked myself when I was Burj Khalifa, right? I spent 2 weeks in Dubai investigating what is the available concrete. Can I trust it? And in fact, what I found out, every single concrete supplier has what I needed. And essentially, in fact, they outperformed what was going on even in the Western countries, even in Europe or some of the advanced countries. Mainly because they had fundamental problems in terms of corrosion. So they had, durability became very important. And durability means that you have to control a cracking, you have to control the concrete very well. If you don't, then you have building that will deteriorate in less than 20 years. And that's the problem they faced actually previously. And many of the old buildings less than 20 years are being demolished because of corrosion. So by just imposing a new standard, a new quality control, and from beginning to the end, you can achieve. We have done also our own tests. We have achieved 100 MPa, no problem. 150, no problem. We have the, many admixtures that we can use to increase the density of the concrete with the right type of mix. You can achieve 200 MPa without any problem. The other thing that is today available, which I think it's a great product, is high tensile concrete, which means you don't need rebar. And if you have the right structure, it's like pouring really, in some sense, steel. Not the quiet, but, and there are many buildings right now is coming up without any rebar, actually. If you keep the concrete in compression, it's fantastic. Example of good Burj Khalifa, we don't have any tension whatsoever in the building, which means I only need minimal amount of rebar. And in fact, if I don't have tension, then all it needs to be in compression. And that using high strength, it's a huge advantage, actually. So practically you're casting the building in place, but you have to have the quality control and the contractor who's able to do it for you. Yeah.
All right, thank you. I'll now like to introduce Chris McCluskey to come up to stage to provide a vote of thanks for Ahmed. Chris is the General Manager, Development Services at ISPT. He has over 25 years of experience in the Australian property markets in both major project development and advisory fields. For the past 17 years, Chris has worked on developments for ASX top 50 public companies and has delivered projects across the residential, commercial, and retail sectors. He joined ISPT in May 2010 as Development Director and successfully delivered the Winter Garden Upgrade project and oversight of ISPT's Queen Street Mall upgrade strategy. In June 2013, he was appointed General Manager, Development Services, and now leads ISPT's National Development Business, overseeing a $2.5 billion diversified development pipeline with major office and retail projects in Perth, Melbourne, Brisbane, and Sydney. Would you please welcome Chris to the stage?
Well, on behalf of ISPT, I'm delighted to be able to offer a vote of thanks. Ahmed, thank you, and Joyce, thank you. Firstly, can I say to the organisers for for the planning of arranging the presentations this morning, which sort of allowed us to elevate our thinking to much loftier heights in terms of our cities, particularly on the East Coast, and the way that they are perhaps going to be composed in the future. And then Ahmed has brought us back down to earth in terms of the technology and the science and the nuts and bolts, literally, of how these major buildings are composed. And as an investor in big buildings and small buildings too, ISPT is fundamentally interested in the way that we produce our assets and the way that we consider the assets that we acquire from others. I think one of the most important things that I learnt this morning, Samsung is obviously a well-known brand to us all, but perhaps not so many of us were aware of the extreme diversification that that business has, and I feel sure that we will be hearing more from Samsung in Australia in the not-too-distant future. There are a number of questions that are posed from Ahmed's presentation as well as this morning's discussions. And if I could leave you with a couple of questions, and they are about the things that we're thinking about in this nation, is what is the economic case for developing our cities in the ways that we have been talking about this morning? Where is the affordability and where is the economic function that will drive the development of our cities? And I think that then leads us to some questions about whether our system of government in this country will allow us to develop our cities in the way, the Federation of States, that is to say, will allow us to develop our cities in the way that many of us believe is possible, and whether the policy settings will exist for us to do so in the future. So if I can leave you with that, I'd like to, if you could please join me in thanking Ahmad Abdelrazaq from Samsung and Joyce Lee from Arup. And if I could invite Mark Dooner to come up from the BDA.
Good morning, everybody. My name is Mark Dooner. I'm the Executive Director of the Brisbane Development Association. We're delighted to be supporting this event, and lunch is waiting, so my comments are going to wait. Please make sure you take your personal belongings with you, as the entire room is going to be reset. But when you come back at 12:30 for lunch in this room, you'll be sitting in the same spot. So please thank all of our speakers from this morning. And please follow the directions outside onto the decks and wherever else for some refreshments right now, please. Thank you.